topic is EIA, EMP and EA. We will come back to that before we conclude this, and I'll talk about all of them because these are also very important aspects nowadays. One important thing that is electrostatic precipitators that we have been talking of. To see an electrostatic precipitators, how it looks like is what is the generally, please take this diagram down. You see, this is what is we generally, in all cases, as you can see, in all cases we have to create a charge, potential difference. Mostly for this one is required for the case of this electrostatic precipitator. And as you can see, what I have, these two are important, right? These two are repeated only on this kind. The dotted portion is only a repeated, only the repetition of these two blocks. What is this says is grounded collector plates. Grounded collector plates. So you have a negatively charged discharge electrodes. This is about, say, this one, this discharge electrodes. These are the electrodes. These are the electrodes that you can see. These are the electrodes, and these are the grounded copper collector plates, grounded collector plates. So what happens here is, this is just to understand that this is not a single column. There will be multiple columns of this in the electrostatic precipitator. They say there may be, say, about 1,000 such blocks where there will be two grounded blocks insulated by another two grounded blocks, and in between there will be three or four positively negatively charged discharge electrodes, and the potential difference, as you can see, can rise up to 100,000 volts. 100,000 volts. So heavily charged electric grounded collector plates would be used, through which the air would be passed. So through which the air would be passed. So you can see the movement of air would be from here. Movement of air would be there from this. As this air flows in through this electrostatic precipitator, what happens is like this: a strong electric field is generated, as you can see, generated between the wires and the grounded plate. Grounded plates. The intense field causes ionization of gases and particulates inflow. Remember, it is inflow. The intense field causes ionization of gases and particulates in flow, and the negative ions, charged ions, move towards the grounded plate, and particulates stick and particulates stick and finally loosen to deposit at the bottom. Right. If they are deposit at the bottom and from the bottom they are removed. So, from the bottom there, what is happening, let me explain you this. So, this gaseous particles here, say all this, the air that is moving in, so the air moving in having gases and they are being passed through these negatively charged discharge electrodes. Now, as they pass through this, as they pass through here, as they pass through there, they get ionized. As they get ionized, they would be repulsed from the negatively charged poles, isn't it? And they would move towards the relatively positively charged grounded collector plates. They would go there and collide with the grounded collector plates. Many of them would remain stuck to the grounded plates. That is also possible, but particularly the magnetizing substances. And then after that, the gaseous part would generally travel upward. They cannot remain stuck. The gas would move upward, but the particulates would remain stuck to the grounded wall, and they would be either by gravity they would settle at the bottom, and otherwise after periodically the grounded plate has to be cleaned so as to get rid of all the particulates. So, this is also the same thing as I have said, that there will be a number of scores of electrostatic particles, electrostatic chambers like this, which would be set, and many of them would look like, particularly if you observe this, say this is how it would look like, almost all of them. As you can see, this is from where this would be sent through, and you can see the columns, a number of columns of electrostatic precipitators, one after another set, one after another. This is from where this the voltage would be generated. This is where this negative voltage would be generated. These are the other aspects of that, and this through which this particularly through these outer surfaces the particulates, the gases would be coming out, and the particulates would settle at the bottom. The particulates would settle at the bottom here, or would remain stuck to the grounded filaments or grounded collector plates. So, right. This is what is mostly how it looks like. This is how it mostly looks like. So, this is what is in electrostatic precipitator. Nowadays, in very common in use. Actually, is very common in use. Almost all power plants today use them. Almost all cement plants use them. There are many other industries where this is where there is a locality very close by. There is a locality very close by. These are mandatory. These are mandatory, and we should know about them. So, okay, this is about this mostly the electrostatic precipitators. Briefly, what it is, a working principle that we have discussed. And the second one, the next in the line that we would discuss today is this, particularly is the bag houses. If you have seen the say the dust cleaners at home, you have seen these bags almost. What is there? There inside that is inside the most of these vacuum cleaners that we have seen. Just open the vacuum cleaner, you have seen a bag house. What is there is inside that is a particularly, if you just observe, if you just see this, the bags that we generally observe here it is like this. Mostly you will find that this is a bag which is looking like this, and through which, you know, this is where, if you remember having seen them, this is where okay, say this is called fabric filter. It's basically made of the paper mesh, or say by and say treated clothes with high density of perforations of 1 to 1.5 to 2.5 micron size. So what is happening here is, so the air enters through this, as in a vacuum cleaner, as the air enters, the air is sucked through the dusted air, this dusted air. So out of this dusted air, here you can see the dusted air, the air would pass out, perforate through the perforations, and the particulates should be arrested on the bag itself. The perforation should be these particulates should be arrested in the bag itself. So you just create a say positive pressure on the other side, so that, you know, as the air would essentially from the positive side to the negative side, as the air would move out from the bag, the particulates should be arrested in the bag, and this bag would be time to time cleaned, and many of them in many a time it would be many of this dust particles, when it is, I mean, having no velocity, when it is steel, it would generally come down through the column. Okay, only when it is with energy, you know, it would travel, otherwise it would generally settle. So more than the critical velocity that you know. So here also the same thing, and when it says this is a typical bag house, whereas all these things are it's columns of bag houses like this, 1, 2, 3, 4, 5, and then on the other side, so you can see 6, 12, 18 kind of bag houses, and through which, you know, the air enters through a common entry and directed to each of the bag houses, and this through these bags the air would go out mostly, and the particulates would settle. Some of them would remain stuck in the bag, and many of them would settle down. This is also a very typical, very common type of bag houses that are generally used. This is, just write down a line here. The part of the filtration is significant part of the filtration is caused by the inside accumulation of the particulates in the bag, or in the bag or bags, right. These are efficiencies. If we just observe the efficiencies, this part is drawn. Efficiency can be 100%, for PM 1 micron, and about 80% for PM 0.01. So PM1 and 0.01. So these bag houses are becoming extremely popular nowadays. More and more they are replacing electrostatic precipitators now. Most of these bag filters, because wherever the new filtering is being done, electrostatic precipitators are being discarded as against these bag houses. The reason, one of the big important reason is the consumption of energy, because the energy being scarce, mostly in the power plants. I mean, in particular areas in India, various plants you will see the energy is scarce. They are actually worried about energy. So this one relatively requires less energy. Only the bags have to be replaced time to time. Bags have to be cleaned and maintained time to time. So with that, this method is becoming more and more popular, these bag houses. Okay. So I have mostly discussed about this air pollution control methods. These are the standard, very popular industrial air pollution control methods. Now, having gone from here, I'll just briefly discuss about this. Mostly the most important thing that is we should talk about is EIA, EMP and EA. EIA, EMP and EA. EIA stands for environment. I think let me explain here as I have come in. So this air pollution control is complete. I mean, so we have completed this. So these are additional topics of environmental control nowadays. Is very important for engineering projects, mostly because very important for engineering projects. So I'll just briefly discuss about their main objectives and what they try to do. Say environmental impact assessment. The environmental impact assessment is, I think, if for any large industry, it has become now mandatory to have environmental impact assessment before they are allowed to operate. For most of the industries, particularly any large industries where there would be some kind of production, some kind of manufacturing, there is mandatory now to have environmental impact assessment to be carried out. I mean, environmental impact assessment has to be carried out so as to get certification to carry on with the manufacturing or production job. Now, what is this? Environmental impact assessment deals with qualitative and quantitative estimation of likely changes in the environment if a production or manufacturing work is carried out in a site. In today by Government of India, GOI, Government of India orders EIA is mandatory for all large projects say more than 100 crores including construction. So what is done? So this components of EIA says components of EIA. The components of EIA say this, say current status, of related to air, water, soil, noise, vibration, prior to right. The current status, what you first out the stages, components, say stage 1 or say component 1. The most important thing is to obtain the values of current status of environmental parameters related to air, water, soil, noise, vibration, specific contamination, etc., prior to the start of the project. I mean, the project has not been started, but you can have a general assessment. Say something, what is the quality of water, what is the TSS, TDS, then dissolved oxygen, or say the particular amounts, say sulfate, bicarbonate, the ferric ion. All this can be estimated for water. Similarly, for air also you can find out what is the concentration of oxygen, nitrogen, sulfur dioxide, carbon dioxide, carbon monoxide, all these things prior to the startup of the project. And also related to this is related to soil, the typical soil parameters that you know of, mostly that we have known of: soil acidity, the soil organic matter, soil texture, structure, all this, and says noise, vibration, what is the ambient noise, what is the background noise, all these things can be found out. Vibration, say specific contamination, suppose if any it is already being done in a contaminated site. So what kind of contamination had take place? Say general contamination may be nickel, copper, cadmium contamination of the land, or say water if it is lead enrichment of the water, or arsenic enrichment of the water. Whatever is the status, the current status is the component of EIA. This is what the EIA should be composed of. Second thing that should be is the say from this impact assessment. Now you would consider the impact part. Impact part is the likely impact likely impact of the stage 1 parameters after the project is started and worked for a year, or so. This is a likely impact. Remember, these are not taking place actually. These are likely. This is what is in a how do you do the likely impact assessment? Suppose you say, you are going to produce 10 million ton of coal. The 10 million ton of coal, if it is say if you are working on a striping ratio, say 1:3, that means 10 million of coal, there would be about 50 million of overburden. That has to be cleared. So you have produced, you are going to dislodge about 60 million tons of material. If 60 million tons of material is dislodged per year, what is the likely effect on that in matters related to say dust, in matters related to say carbon dioxide, in matter related to water quality? All this, what are going to be the likely impacts? This is what has to be found out at the stage 2. This is what the likely impact this is. And the third one we generally do is we make an futuristic assessment, likely impact of the stage 2 and other additional parameters after 10 years of the project startup. Current status, likely impact stage is 10 years. After 10 years, this is after a year or so, this is before the project is generally done. This is called the EIA. This is what has to be. This generally for a mine generally is conducted by a third party consultant. Say in India, this kind of projects are generally done by, say, IBM does for mining companies. Indian Bureau of Minerals does this for mining companies. There would be say Engineers India Limited does it, NIRI does it. So there are many agencies which you have to appoint as a consultant, and who would carry out, say suppose you are thinking of opening up a mine at a certain place, or you are going to establish a plant at a certain place. You have to appoint all these organizations, some of these organizations, to carry out the work for you, and finally they would give a report on what they assess are likely to be the impacts if the project comes through, or if the plant is set up or the mine is set up, and then this has to be supplied, this has to be given to the Ministry of Environment and Forest, state government, for permission to carry out the industrial work. Okay, not before that you cannot get through. You would not be surprised that many organizations, in many mining organizations, the expansion is being stalled because of non-clearance of this kind of materials. Like Kudremukh is stopped as a mining organization, you might be knowing. There may be many other organizations, like many other organizations in India. Say various construction projects are held up, or they are not given permission just because they are not fulfilling this. If a government or a state government understands that the impact is going to be very heavy, it might disallow a company to carry out the project work, the construction work. So this is what is the components of EIA. Having done the EIA, the next the company would do this environmental monitoring plan. which we know as EMP. This also has to be supplied, and then with these two things have to be supplied to Ministry of Coal, Ministry of Environmental Forest, Ministry of Industries, Ministry of sometimes Ministry of Commerce might also ask for it. So there may be various state agencies that they would ask for. Say what would it be? We now know by EIA that these are the likely impacts going to take place. So how we are going to reduce or minimize the damage? That is the what is your environmental monitoring plan. So the environmental monitoring plan would have environmental monitoring plan would have number one, the steps will take to mitigate the effects underlined by EIA. Say for example, what it would try to do is, for example, what are the things, say something like, as say if it would form terraces, it would form, it says that I will form a catchment area, or I will create a sediment pond, I will create a water treatment plant, I would use dust sprinklers, so all etc. So you can see, you can think of whatever kind of things that are required, say water treatment plant, different types of water treatment, primary, secondary, tertiary water treatment plants that we have known of. So all this the project, the mine, the corporate, the organization would ensure that they would form, they would make. This is the first step in EMP. Next step is this. The next step it says is the method of monitoring, the parameters, say period wise, say something 24 hours, say weekly, bi-weekly, 6 monthly, annually, etc. The method of monitoring the parameters period wise. What is the method of monitoring? So something like what it would monitor is say the for example what it would make is SPM, then RPM, then TSS, TDS in water, then say vibration PPV, right, P wave, S wave, as you know. So this says in vibration, the noise in the decibels. So all this, this would in a particular plan, and as also it would also say the method of monitoring. Another important thing is the locations. The locations would be the location should be the inside the plant, in the villages, etc. Locations inside the plant, in the villages, all these things. And finally, the method of monitoring and also reporting the status, highlighting the crossover of the critical pollutants from the national standards, reporting the status, highlighting the crossover of the critical pollutants from the national standards. That it has to mention. This is what is EMP. Essentially, this is what is EMP. EMP carries out this thing. The basic things are typical, 24 hours, whether it is 8 hourly, 24 hours, or say once, twice, once in 2 days, or once in a week, once in a year. All these things have to be reported, and also wherever there is the status highlighting the crossover of the critical pollutants from the national standards, and finally the methods of reduction implemented. Methods of reduction implemented. What are the methods of implementation? You have methods of reduction. What are the methods of reduction you have done? This has to be how it has been implemented. That has to be said. Say if a particular, if you say mixer or say dozer or a heavy earth moving machinery is causing a tremendous amount of noise, how you are reducing the noise? What is the method you have applied? All these things has to be documented. So it's mostly about that. So this is EMP. So basically there are two. When this EMP is generally given to the government, the company says how it is going to do the EMP. If there is how I am going to measure the peak particle velocity I am going to measure per blast or for every 2 blasts or things like that, that it would mention that I am going to follow a certain standard like this, and I am going to stick to this rule, right? These are very, very important things. So anyway, whether a particular company follows the EMP in true sense later on is a different question. There are monitoring agency to judge whether they do it or not, but they have to, in writing, they have to assert, they have to say that we are going to do these things. If it is producing water of a very poor quality, it would has to say that I am going to bring down the BOD, the BOD from 10,000 milligram per liter to 1000 milligram per liter. That has to mention in the EMP itself, and then finally the EMP has to be implemented. EMP is a standard regular day-to-day exercise that the mine generally carries out. Okay. And the final the topic that of the course is environmental audit. Environmental audit. Environmental audit, or also known as EA, that is environmental environmental audit. In a plant to internally assess. This may not, this environmental audit may not be a statutory requirement. It is not necessary. It is not necessary that it has to be a statutory audit. Environmental audit is generally carried out in a plant to internally assess and physically verify, that is audit. Internally assess and physically verify the energy, the material and energy balances in the input stream, raw material, water, energy, okay. These three, raw material, water and energy, say, or even say pneumatic power, whatever energy, as you can, as we have discussed, the material, to verify the or audit the material and energy balances, material and energy balances in the input stream, and in the output stream, that is number and amount products, say, if it is say products can be number of physical items, electricity, etc. Products, number and amount of products, number of physical items, electricity, etc. Waste, like say flue gas, say and recoverable energy and material. So, what it is trying to energy material. So, if you just see this sentence again, environmental audit is generally carried out in a plant to internally assess and physically verify, that is auditing, the material and energy balances, that is, input and output remaining same, as is, thermodynamically they should be same, isn't it? So what is input should be also be output. So it's a conservation of mass and energy. So this material and energy in the outputs, in the input stream, raw material, water, energy, and in the output stream, number and amount of products, number of physical items, electricity, etc., waste, flue gas, gaseous pollutants and wastewater, and recoverable energy, material, etc., energy and material, etc. So this is the balances that we generally do. So the input should be equal to output. So if this whether anything is recoverable or not, whether this can be reused or not, this is what is, with all this, with the idea to, you just write that, with an idea to improve resource efficiency, and with an idea to improve resource efficiency. How an organization can use its resources efficiently without wasting them? Where are the scopes of improving? So the first few things, as I have said, if you are just trying to observe that EIA is the assessment part, how much damage it is going to make. EMP is considering that the damage will be made. What are the methods and practices we should use to measure the damage and also to contain the damage? Then the third one is EA, which would say the internally whether there are, we would check and balance whether the input and output streams are balanced or not, whether they are, the conservation of energy and material is practiced or not. I mean, how way this can be. If this is having see that, having observed that there is a scope for improvement, increasing the energy efficiency, increasing the material efficiency is the idea finally. So in the environmental audit part, we will just look for the more efficient means by which the energy, the material can be used. Okay. So these are the three perspectives of EIA, EMP, and EA. Okay. Any question?
Sir, EMP is made by the management of particular industry.
No, it's like this. Generally, EMP they can make. In some cases, they are certainly EMP. An organization itself would provide, but sometimes it takes the help of an outside consultant. Yes, absolutely necessary. There are say central authority is, if it is say projects which need central clearances, this would be provided by the particular ministry under which it comes, say Ministry of Infrastructure, Ministry of Energy, Ministry of Steel and Mines, Ministry of Ministry of other things like say related to any other textiles or whatever, agriculture, and MOEF, Ministry of Environment and Forest. So this is for central projects. In where the states are allowed to, permit some projects, small projects of certain size, whether the states can themselves allow. The states can themselves allow. There, the state government, it has to be done with the officials from the state government or state bodies. Say MOEF might have an office in say if it is Bihar, might have an office in Patna. So MOEF Patna would look into the aspects of the state government as well as state governments within itself. It has pollution control board, PCBs. The PCBs are also allowed to intervene. Now, in situations when there can be a case where say a state with the project is under state, but a people or public in general believes that the state and the center should intervene. In such cases, MOEF can be directly involved. MOEF would directly say that MOEF has the authority to intervene, though it does not intervene in state things generally, but in exceptional cases MOEF has all the power to intervene in state matters. So, in such cases it would be referred to MOEF again. These things continue, it's a majority, most of the industrial projects today in India, in countries like India and many other developed countries, it is extremely difficult to get environmental clearances. Many projects are held up because of that. Unless an organization comes up with, say, EMP. I forgot to mention one thing in the EMP is that afforestation is also a part of the activity of EMP. It says in most of the projects, construction projects, mining projects, we talk about compensatory forest, which means whatever forest area or whatever vegetative area you have dislodged or displaced, equivalent area has to be developed in some other area, either within the project or outside the project, at the cost of the company, at the cost of the corporate. So, this is also a part of the EMP that it has to show, and generally it is becoming a must now. And another important thing is particularly for critical industries like chemical industries, mining industry, say then power plant. You see very recently, you might be knowing, there are a lot of, say, uranium mining. There is a very strong protest which is being carried out against uranium mining. The things are mostly, you will find that the Ministry of Environment and Forest has not cleared those projects. But again, the compromise is that you need energy also. You cannot help. You need energy to develop. I mean, a country like ours required it to develop. But at the same time, it might go against the development. It might goes against the environmental aspects. So, this is a conflict. This is a conflict that would remain. That would remain for, and it would intensify over the years. It would be more intensifying, because you will find more and more troubles coming up due to that, because now the situation is the public is getting directly affected. Public is getting directly affected, because you see in many cases the cities, if you just see in last 5 to 10 years time, the number of vehicles have increased by about 100% in almost all cities, and this has a direct correlationship with the rise in the breathing problems of children and adults. So, when the public is getting seriously affected, so there would be a backlash also. There would be a certain thing, the companies as a result of that are going for stringent environmental norms. So, these things should carry on, these things should keep on happening. I think with this we come to the end of our lecture series. I think about this environmental pollution control is complete for all practical purposes. I think I have covered a large part of this subject. Okay.